Graphing this under normal circumstances, we put an open circle around 2, and we want x is greater than 2. That would be the information to the right. Maybe. There we go. Now the thing that we're going to throw in is a domain, meaning the allowable points that x could be. In this case, the domain, that's what the D stands for here, domain, is the real numbers. What's the set of real numbers, class?
Any number.
Any number. Any number. Decimals, fractions, irrational numbers, rational, all that. That means that any one of these points would be in the real numbers, because any number is a real number. So your graph would simply look like this. That's what we've been doing. We've been graphing these without a domain. We've just been assuming that it's real numbers. So that's what this one looks like. Now if we do this, next problem, we want to graph this where the domain is the integers. So we're going to take this negated value, and on the test the other day, this was the type of problem we didn't do very well on as a group. This becomes x is less than 3. Remember the trichotomy axiom? When you compare any two numbers, there's 3 possible outcomes. They're either greater than, less than, or equal, and if I'm crossing out 2 of those, then it has to be the third. Okay? So, x is less than 3, so that's an open circle on 3. And I want the values that are less than, which is to the left, but I just want integer values. What are the integers? Okay, -1. What about these 3? Aren't those integers as well? Yes. 0, 1, and 2 are also integers. And to show that that would continue in that direction, we would just highlight the arrow piece. Would you have to put an open circle around 3? Meaning, would we even have to highlight 3 at all? No, because we just want the values that are less than 3, the integers that are less than 3. So we wouldn't even have to show that. If you did, I wouldn't count that wrong. But you wouldn't have to put it on there. Okay? Does that make sense? See how that domain limits what you can graph? Okay, graph x is greater than or equal to -1, and the domain is the real, so the real number is what that means. So greater than or equal to would be a solid point on -1, and what the value is greater than that with real numbers. Are the real numbers any number, or do we have to find some certain thing? Any number, so just like normal. Okay, no big deal on that. Graph x is less than -1. So open circle at -1, where the domain is positive integers. I'm with you, kids. Yeah. Austin was back there a minute ago, too.
Wait, are they on the tissue thingy that we have to do?
I don't know.
I think I am.
You better be. You're going to be paying big bucks.
Do you actually take that tissue thing serious?
I know, I'm on the tissue thing because Ethan gave me a box.
They use the toilet paper. Why?
Oh, this is for the non-tissue.
Hey, which points meet the requirement for this?
3.
Kelsey?
0, 1, 2, 3.
Are 0, 1, 2, and 3 less than -1?
Yeah. So it's just 1. No, just 0.
There is nothing that meets that requirement with that domain, correct? There are no values less than -1 that are positive numbers. So the answer to this is this symbol here. It's a 0 with a slash through it, which represents the null set, or the solution empty set. But that's the symbol, is a circle with a line through it. That's the null set. There are not any. There aren't. What?
I just put it equal none.
Put this from now on, because that's the
what I do on
representation.
my lessons. Like whenever the answer is 0, my mom will show me the cross out. That's what I do on my lessons.
Make sure that this is different looking, because it doesn't mean 0. It's just saying there are no points. I mean, it is 0, I guess, but it's a special way of doing it. All right, x is greater than -5, so or equal to -5, where the domain is a positive integer. Well, how would I start marking this?
Circle on 5.
Are we going to have a circle on -5? Is that a positive integer? No. So we're not going to have a solid point on -5, but we could have it on.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah. And of course you wouldn't have to draw out all of that. If I were doing this problem, because we usually put the -5 as our middle point, at least that's how I showed you it, you would need to extend it to the right and go, okay, -4, 3, 2, 1, 0, 1, 2. More so than normal to be able to get to those points. So you'd circle. All right, here we have a value with our variable. If this less than symbol was an equal sign instead, how would I solve for x? Dalton? Subtract 2. We're going to do the same thing with the inequality. We're going to solve for x. So I'm going to still subtract 2. Excuse me. Thanks. So I want to graph x is less than -2. And I don't do anything silly with the sign. I'm just rewriting it. So I want x is less than -2 for the real numbers, which means anything. So I can isolate that x by adding or subtracting values from the sides, but it's like in equality in terms of balance, and whatever you do to one side, you still have to do to the other. Here I have a -3, so I have to add 3. So x is greater than or equal to 8, and I want the positive. Oh, sorry. Yeah, gee. -2, so greater than or equal to -2, and the integers. What integers are greater than or equal to -2? And again, you wouldn't have to draw out that big of a number line to do that. All right. Amazing how much better ultra or puff solution feel on those.
Number 1. Yeah.
look at. Excuse me. Sorry to bother you.
You're
So look at number.
recording.
Nice.